Okay, so now we're going to move on to question 4. Question 4 states, at time t equals 0, a boiled potato is taken from the pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time t equals 0, and the internal temperature of the potato is greater than 27 degrees Celsius for all times when t is greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation dh over dt equals negative 1/4 h minus 27, where h of t is measured in degrees Celsius at h of 0 equals 91. Alright, so that seems like a lot, but I wrote down the key things. So dh over dt equals negative 1/4 h minus 27, and h of 0 equals 91. I didn't write here, but I will write later that the internal temperature of the potato will not be anything less than 27 degrees Celsius. Okay, so A asks, write an equation for the line tangent to the graph of h at t equals 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. So, what I first did was dh over dt when t equals 0 is essentially the same thing as, since we are given this, it's negative 1/4 of h minus 27, but we already know that h of 0 equals 91, so it's negative 1/4 of 91 minus 27. So then we get that dh dt equals negative 16, which is the slope of the line. Now all I have to do is put it into point slope form, so y minus 91 equals negative 16 times t minus 0, or y equals negative 16t plus 91. Now we have to approximate when the internal temperature of the potato at time t equals 3. So basically you just plug in 3 and you get 43 degrees Celsius. Now B asks, use d squared of h over dt squared to determine whether your answer in part A is an underestimate or overestimate of the internal temperature of the potato at time t equals 3. So basically all we have to do is we have to find the derivative of this. The derivative of this is simply negative 1/4 times, since it's h minus 0, it's just dh over dt. And since we already know what dh over dt is, it's just negative 1/4 of negative 1/4 of h minus 27. Again, I'm going to say that again because I don't think I explained it correctly, but so to find the derivative of the second derivative of this, what you do is you find the derivative of this, and based on the rules of derivatives, negative 1/4 h minus 27. The 27 doesn't have any variables, so it crosses out, and the derivative of h is simply just dh dt. So it's negative 1/4 of dh dt, and we already know what that is, so we plug it back in. All right. So now what you're going to do is you're going to simplify to 1/16 of h minus 27. And since we already know, as given in the data in the beginning, that the temperature is always going to be greater than 27, we know that this expression is always going to be positive. So the second derivative is always going to be positive, meaning that's going to concave up. So that means that the tangent line is going to be an underestimate because, for example, if you have a graph and it's concave up, and you have tangent line down here, you can see it's an underestimate than what the actual graph is. So again, since h is concave up, that means that it must be an underestimate. Alright, so now we're going to move on to C. C is arguably the most hard problem, and it's the majority of the points of the entire question. So C states, for t is less than 0, an alternate model for the internal temperature of the potato at time t minutes is the function g that satisfies the differential equation dg over dt equals negative g minus 27 to the 2/3, where g of t is measured in degrees Celsius and g of 0 is 91. Find an expression for g of t. Based on this model, what is the internal temperature of the potato at time t equals 3? So, I just wrote down again the information given. So dg over dt is equal to negative g minus 27 to the 2/3, and g of 0 equals 91. So first what we're going to do is we're going to try and solve it for g. So again, this is what we start with. I personally divide it by g minus 27 on both sides and multiplied by dt. So you get dg over g minus 27 to the 2/3 equals negative dt. And then what I did was I simply just put that on the top by changing the exponent, I made it negative, and then I took the integral of both sides. So in order to solve this out, you just anti-differentiate, and you get that 3 times g minus 27 to the 1/3 equals negative t plus c. And now we're going to try and find for c. So we know that g of 0 equals 91. So what we're going to do is we're going to replace 91 for g and 0 for t. And after some arithmetic, we find that c is equal to 12. But we're not done quite yet. We have to plug c back in and solve for g. So just through a series of arithmetic, you get g equals negative 1/3 t plus 4 all to the 3rd power plus 27. Now, again, it says equate what the internal temperature of the potato is at t equals 3. So you simply just plug in 3, and you get 54 degrees Celsius. And that is the end of question 4.